Hi, boys and girls. Okay, so last week we started with scatter plots, and yesterday, or maybe earlier today, depending on how fast you're working, we looked at trend lines, okay? And we talked about how to make a line of best fit or a trend line, and how to, what one looks like on the graph and how to write the equation for that trend line, okay? So today we're going to write the equation for the trend line, but we're actually going to start solving problems with that trend line or with the equation, okay? Okay, so you see here that we have a graph that talks about time and the calories burned. So how many calories did you burn in any given amount of time, okay? So as the time increases, you see this is a positive association, right? The trend line has a positive slope. As time increases, the number of calories you burn also increases with this exercise. Okay? All right, so it says several members of a gym were asked how many minutes they worked out at a gym that day, as well as how many calories they burned. Their answers were used to make the scatter plot at the right. Write the equation for the trend line. Okay. So when I go to write an equation, I find two things. I need my slope and my y-intercept, right? So I'm just gonna put it right here. My b, or my y-intercept, and my m, which is my slope. All right, remember we write this in y equals mx plus b form. All right, my b, where does it cross the y-axis? Remember the y-axis is my vertical axis. And I see that it's down here. And right here in the corner, that's going to be 0. Okay? So this is a proportional line. I'm not using, I don't have any other numbers to use for the y-axis. Excuse me. So it is 0. Okay? And we'll talk about what that looks like in the equation here in a minute. The next thing I need to do is find my slope. Now I notice it goes up from left to right, so it's a positive slope, so I don't need my negative sign. It's a positive slope. I'm going to use my y-intercept, and I'm also going to use this point right here as the 2 points on my line to find my rise over run. So I'm going to zoom in just a little bit there for you and see if you can see that. Okay, perfect. All right, so from here to here, I'm going to rise, and then I'm going to run, right? Now, looking at my y-axis, I notice it is using 100s to count by. On every line is increasing by 100. So I am going from 0 all the way up here, and that's a jump of 3 spaces, so 100, 200, 300, over. You notice that my minutes are counting by tens. So I have 10, 20. So 300 over 20. Now remember, you can put that into Desmos. It is going to give you a decimal number, but if you click the 2 little boxes on top of each other on the left-hand side, it will turn it back into a reduced fraction. All right. One thing that I do know is that 20 will divide into 300 and 20. So I can divide 20 on both sides. And I'm going to get 15 over 1. Okay, so my slope is 15 over 1. And my y-intercept is 0. All right, so coming back to my questions. Write the equation for the trend line. So y equals, my slope I found was 15 over 1. Remember, I can write 15, or I can write 15 over 1. I'm just going to put 15 today. So I have 15x. And then I have plus b, but I don't have anything for b. I don't have a y-intercept, so I don't have to put it on here. And I'm going to leave it just like this. Now, if I put plus 0, I'm not necessarily wrong, but you're not going to see it like that on any tests or any problems. Okay? So I'm just going to leave it as y equals 15x. That tells me this is a proportional line, right? And we're going to go from there. So what does the x represent in this equation? So that's a good question. We're talking about the number of calories burned in certain amounts of time, right? So in this case, whenever I'm looking for what does the x mean, the x tells me, or my x-axis, right, is going to tell me the minutes that I worked out. The minutes that I exercised, okay? And then the y tells me the total calories burned. Okay? All right, now we're going to use this equation. So when it says use the equation, they're talking about y equals 15x. Remember, y is the total number of calories burned. X is the number of minutes that they exercised. Okay? All right, how many calories would you expect someone to burn if they spent 120 minutes at the gym? So we know 120 minutes. We know this is x, right? I'm going to zoom in just a little bit. So I'm going to use that same equation I had, y equals 15x. But in this case, I know x. So I'm going to put y equals 15 times, instead of x though, I'm going to put 120. You have the ability, the luckiness, I'm trying to think of what I'm looking for. Advantage, there we go. You have the advantage that you have Desmos, right? So in Desmos, you can do 15 times 120 and you get 1800. So you can expect that if you exercise for 120 minutes, you would burn 1800 calories. Okay? Any questions on that one? All right, perfect. Now we're still going to use that same equation here, y equals 15x, okay, on this one. But let's read. If someone has burned 1,740 calories, how many minutes would you predict they spent? Well, what do I know? I know the number of calories, and in this case, the number of calories is actually y, right? This is the number of calories in the time in minutes. So on this equation, I actually know y. So I'm going to put 1,740 equals 15x. Now, we've all passed 6th grade, right? This is something we did in 6th grade. How do I get that x all by itself? How do I get rid of the 15? What's the inverse operation there? Right? 15 and x are multiplying, so the inverse would be to divide. And so I'm going to divide both of them by 15. That gives me 1. So x is going to be equal to, and you have Desmos, 1,740 divided by 15 is 116. So what that tells me, in order to burn this many calories, I have to work out for 116 minutes. Remember, y is the total number of calories, x is the number of minutes. Okay, let's look at number 3. What is the slope of the trendline equation and what does it represent? So we have y equals 15x. What part of this is the slope and what does it represent? Okay, remember slope. Slope can also mean rate of change. It can also be your constant rate. Okay, those are some other words we can use for that. My slope is this 15. That's my m, right? So this 15 tells me this is the number of minutes that I'm going to burn 15 calories per 1 minute. So my slope is 15, and people burns about 15 calories per minute. Okay. All right, let's look over here. So again, y equals 15x. The question says, what is the y-intercept of the trend line equation, and what does it represent? Now, if we look back up at our problem, we found out that our y-intercept was at 0, 0, right? So the y-intercept for this trend line, so b equals 0. The y-intercept is 0. Now, what does that mean? If I have 0 minutes and 0 calories, that's what my 0, 0 means, right? 0 minutes and 0 calories. That a person who works out for 0 minutes, what's going to happen, boys and girls? They would burn 0 calories. Okay? All right, perfect. Okay, so now we're using these trend lines to help us solve some problems. We're using the equation from the trend lines right now. All right, number 5. Julian made a scatter plot to show the number of band members in his school over the years. The trend line of his scatter plot was had the equation of y equals 13x plus 45. And I'm just writing that down again for me. Okay, remember this was a scatter plot. And the y represents the total number of band members, and the x represents the number of years since 1990. So if I'm looking at that, here's my graph, right? So this is going to be the number of band members. And down here, these are the years since 1990. Okay, that's what that graph would look like. So you've got the points all over. Okay, so now we're going to use this equation to solve the problem. How many students would you predict to be members of the band in 1997? Okay, this right here is our big thing, because this is the year from 1990. How far is 1997 from 1990? Right? So this is 7 years. And it told us that x represents the number of years since 1990. So we're going to replace 7 for x. So we're going to say y equals 13 times 7 plus 45. And again, we have that wonderful advantage of Desmos. So there I'm going to do 13 times 7 and I get 91 plus 45. So 91 plus 45 is going to give me y equals 136. I can assume that there are 136 band members in 1997. Excuse me for yawning. It's late. All right, how many students would you expect to be members of the band in 2010? Again, we're using the same equation, so y equals 13x plus 45. I need to take my date, and I need to find out how far that is from 1990. Okay, can anyone tell me how far that is from 1990? That's 20 years. Good. Okay, so I'm going to replace this 20 for the x. Okay, so I'm going to say y equals 13 times 20 plus 45. Again, I have my handy dandy Desmos, and I can go in and do 13 times 20, which should give me 160. And then, or 260, I'm sorry, 260, and then plus 45. So y equals 305. So there should be 305 band members in the year 2010. All right, last question on this one. In what year would you have to expect, or would you expect the band to have 370 members? So y equals 13x plus 45. All right, so we know something different this time, right? We know the number of members, which when we read earlier was y. So we actually know that this is 370 equals 13x plus 45. Now, this is something we actually haven't quite done yet. You might have done that at the end of last year, but this is a two-step equation. Okay, so we're going to solve this real quick. Just follow along. If you notice, I left something out. What did I leave out? I left out my x. Okay? All right, so my thing here is I'm trying to solve for x. I knew what y was, now I'm trying to solve for x. So I like to draw a line, and I like to protect my guys with the x, okay? So when I protect him, that means I want to take away anything that I want to get rid of, anything that's near him. And in order to do that, I do the inverse operation. So I'm adding 45 here. In order to move that, I'm going to subtract 45. But I can't just do it to one side. I have to do it to the other as well. Okay, so over here, I've moved it because 45 minus 45 is 0. Now over here, I have 370 take away 45. Again, handy dandy Desmos. 370 take away 45 is 325, but I still have this 13x. Okay, now remember, I knew what y was, but I'm trying to solve for x this time. Okay. Okay, so in order to break these up, I'm going to divide. So I'm going to divide 325. 325 divided by 15. No, I'm sorry, divided by 13. Okay? 325 divided by 13. Now 13 divided by 13 is 1. So I know here that x is equal to, when I do 325 divided by 13, I get 25. Now, I want to stop for a second. Is 25 the answer? Is that the year that there are 370 band members? Right? That's kind of silly. Does that really make any sense? No, right? Now, I want you to go back and look in the problem of what does x actually mean? Right? X represents the number of years since 1990. So this is 25 years since 1990. So we need to add that together to find out what year we're in. So here's 1990 plus 25. Okay, and when I do that, I get 2015. So the year was 2015. Okay, so sometimes there are multiple parts of those problems. Sometimes just because you find the x or you just find the y That doesn't always necessarily mean you're finished. Go back and read that problem and make sure you know what it is that you're talking about. Make sure that your answer makes sense. Okay, and we've talked about this before, the reasonableness of things, right? Is it reasonable? If your answer doesn't make sense, it's probably not right. Okay? All right, let's look at the second page real quick. It looks like it's a lot of the same page we just had. So I don't think I'm going to do this part, okay? Or the top part, because I want us to save a little time and give you more time to work today. So I'm not going to do this. This is like the front. Okay? That part is. Okay, but I do want to talk about this one on the bottom. All right, so this one says a scatter plot was created to show the temperatures based on the altitude above sea level. Altitude means how high you are above sea level. The equation F for the scatter plot, or the equation for the scatter plot's trend line is y equals negative 0.0035x plus 59. Y represents the temperatures in degrees Fahrenheit, and X represents the distance above sea level in feet. Okay? So use the equation to answer the questions below. So first of all, what type of association would you expect this scatter plot to exhibit? Okay, you know your trend line's going through the data. What do you notice about your slope of your trend line? It's negative, right? So what type of association would you think this would demonstrate? A negative association. Because the slope of the trend line is negative. Okay? All right. Now remember that y equals the temperature and x equals the distance above sea level. And I have y equals negative 0.0035x plus 59. This is my equation, right? Okay. Boy, howdy, that's a good one, right? Thank goodness I have Desmos, because I am not about to try to figure that out tonight, especially as I'm at home tonight trying to video these notes, because it is super late. All right, so I know 10,000 feet above sea level, which is going to be x. So y equals negative 0.0035 times, instead of x, I'm going to put in 10,000 plus 59. That's up here in this problem. Okay? I'm going to put that in Desmos, guys. I'm not going to try to figure that out tonight because I'm afraid I would get it wrong. All right, so I have negative 0.0035 times 10,000 plus 59. And I get an answer of y equals 24. Well, y is what? The temperature. So y equals 24 degrees. Okay. And then lastly, predict the distance above sea level if the temperature is 35 degrees. Round to the nearest tenth. So y equals negative 0.0035x plus 59. In this case, I know the degrees, I know the temperature, I know the y. So this is 35 equals, all right, remember I'm going to protect this little guy here, get rid of everything around him. I'm drawing that to split the equal sign, so I'm going to do the inverse operation in order to move this. And since they're adding 59, I have to subtract 59 in order to do that. That's going to equal 0. And 35 take away 59 may not be the sharpest on our integer operations. So guess what I have? My handy dandy Desmos. So I'm going to do 35 take away 59, and I get a negative 24 equals negative 0.0035 x. You're still trying to get that guy safe. All right, it is finally time for him to venture out on his own, so we're going to break these two up. Since they are multiplying, we are dividing. So we are dividing by this on both sides. These equal 1. And so that leaves me with x by myself. And I'm not even going to attempt to figure this out. So 24 divided by negative 0.0035, right, equals I typed in something wrong, guys. Sorry. I don't know what I was. Okay, so I'm going to back up just a second because I typed in something wrong and then it messed me up. Okay, so what I'm typing in is I am typing in negative 24. So negative 24 divided by negative 0.0035. And I get the answer 6,857.14285,714. Okay? Is that reasonable? I don't know, Miss Pond. There's a whole bunch of numbers there, right? So let's see what we need to do. Go back up and read the last part. Round to the nearest tenth. Tenth is 1 decimal place. This 4 tells this 1 to stay a 1, and you'll leave everything else alone. So x is equal to 6,857.1. And this is feet above sea level, so feet. Okay? All right, guys. You got this. You have a test on Thursday, I believe. So we're trying to get ready. All right. Get busy.